Let's talk about solving some multi-step equations. I've got a few examples for us. I'm going to take us through these three. When you are solving multi-step equations, the first thing you want to do is focus on each side individually and make sure that everything is completely simplified as much as possible before you start moving things from one side to the other. So let's take a look at number one. Looking at the left side and the right side separately, there's nothing I can do to simplify any further. There's no adding, subtracting, multiplying, or dividing that I can do. This is as simple as it's going to get. So I'm going to start by taking this plus x and moving it to the left-hand side. Since it's being added, I need to do the opposite of adding x, which is to subtract x. And of course, I do the same thing on the left-hand side of my equation. I combine like terms. I have two x's. I'm taking away one x, so now I have just one x. And you don't need to write that one if you don't want, because if I were just to have x here, that does imply that there is just one of them. I would need a coefficient specifically to tell me there's more than one. If there's no coefficient written, then we assume that it is just 1x. I didn't touch that plus 3 or the 7. Now I've decided that I want my variables on the left, so all of my constants, or everything that doesn't have an x, needs to be moved to the right. So this plus 3 needs to move to the right-hand side. Since it's being added, I do the opposite, which is to subtract 3 from both sides, and then I have x is equal to 4, and that is it for our first equation. Let's look at number 2. Again, whenever you're solving a multi-step equation, you want to make sure that you simplify completely on each side first. In this equation, there is some simplifying that I can do. On the left-hand side, I have parentheses here, and in front of the parentheses is a 3, which means that that 3 is being multiplied to those parentheses. So I'm going to take that 3 and distribute it in, giving me 3 times x plus 3 times 4, which is 12. And on the right, I have the same thing, but now it's a 2. So I end up 2 times 2 is 4x plus 2 times 7 is 14. Now I've simplified. There's nothing else that I can multiply, add, subtract, divide. So now I start moving things from one side to the other. I want all of my constants together on one side and all the variables on the other. Now, when you decide which side your variables are going to be on, you might want to think about keeping the variables positive. It doesn't always make a huge difference, but sometimes it can be helpful. So think about taking this 4x and moving it to the left-hand side. If I do that, I'm going to subtract the 4x from the right and from the left. Now notice that when I go add the 3 and the negative 4, I'm going to end up with a negative number. And that's just a little bit annoying. There's no problem with it, but it's a little bit annoying. So usually what we'll do is we'll keep the bigger one where it is and move the smaller x to be with the bigger one. So I'm going to move the 3x by subtracting it. I have 3 x's and I'm taking all 3 of them away. And on the right-hand side, I subtract my 3 x's. On the left, I have just a positive 12, and on the right now I have x, and then I have plus 14. Now I have my variables all together on the right, so I need everything else over on the left. So let me subtract my 14, moving it over to the left-hand side. I simplify on the left. 12 minus 14 is negative 2 equals just x. Now, if I rearrange this and just flip the whole thing over, I have x is equal to negative 2, and that is it for our second equation. Let's go ahead and do one more. Just like in our last two, we want to make sure we simplify completely on each side before we start moving things from one side to the other. So to simplify this whole left side, there's a lot going on. I see 2 different sets of parentheses. So if there's any number in front or any exponent, I need to make sure I take care of those. You could think of this as having an invisible 1. And when I distribute, 1 times 4 is 4x, 1 times positive 5 is positive 5. Now the second parentheses does have this negative in front, and that is actually a negative 1. Same thing we've talked about before. If there's no number showing, we can imply it's being multiplied by 1. So this is a negative 1, and when I distribute negative 1 to negative 2, I get positive 2x. Negative 1 to positive 11 gives me negative 11, and I didn't do anything to the right-hand side. Now the left, I still need to combine my like terms. I see 4x and 2x. When I add those, I get 6x. And then for my constants, I've got positive 5 and negative 11. When I add those, I get negative 6. Now on the left-hand side and the right-hand side separately, there's nothing else I can do. This is as simple as it gets. So now I'll start moving my like terms. I want variables on one side, constants on the other. I'll keep my larger variable where it is. So this 6x is going to stay here. I will move my 1x by subtracting. Since it's a positive x, I'll subtract to cancel it out on the right and give me 5x's on the left. Now I need to move my 6 to the right-hand side since it's being subtracted. I'll go ahead and add that 6 over to the right. 5x equals 10, and then my very last step is just to divide out that coefficient of 5. Since it's 5 times x, I divide to isolate my x, and I have x is equal to 2, and that is it. And that's a little about solving multi-step equations. Hope that helped. Thanks for watching, and I'll see you next time. Bye.